link analysis is the study of relationship between nodes, which is quite relevant to the few topics we've been learning this 2 weeks. So in link analysis, there are 2 different categories. So firstly, on your left would be the link-based object classification, which is to actually study how you can assign class labels to the nodes according to their link characteristics. So for example, the number of edges they have incident on them. And we'll do it through iterative classification and relaxation labeling. And the other category is actually link-based object ranking. So you want to actually rank the objects according to how important it will be. So you will look into factors that will affect their importance. So that would be the kind of algorithm we use would be page rank, hits, and sim rank, which is not our focus for today. So our focus will be on a link-based object classification. So one very clear application of that would be social network analysis. So how everything started for social network analysis actually is due to the case of Hudson School of Girls in 1933. So at that point of time, during 2 weeks, in a period of 2 weeks, 14 girls actually went missing, which is missing from school. So it's actually a rate of 30 times higher than normal. And this psychiatrist, Jacob Moreno, actually found out through this graph that she has drawn that the girls actually ran away not because of their personal motivation or personalities, but more from the way they behave in their social network. That means like if one person is missing from a cluster, then everyone else nearby is missing. So that means the girl is very important, and that's how it affects everyone else. Yeah. So basically, so for social network analysis, you aim to study the social relation among the entities. So it can be distance, flow, social roles, or as well as affective, such as whether you like or dislike, etc. So usually when it comes to social network analysis, one question that we always ask is, who is the most important or central person in this network? So to do that, we can actually look into degree as well as closeness. So what is degree? So for degree, right, you actually want to assign an importance score based on how based on the number of links held by each node. So in common sense, it would be how many direct connections each node has on other node within the network. So why do you need to do that? Because maybe sometimes you want to find the most connected individuals, the most popular one in the entire network, maybe the one with the most number of followers, etc. on Instagram, or like friends in Facebook, etc. Yeah, so here is a quick illustration of how it will look like. So you can see that as it goes by, the number of the closeness, the degree actually decrease. Yeah. So next we will look into closeness centrality. So you will study how close other nodes are from the node you are looking at within that network. So in other way, you are trying to calculate the shortest path between all nodes, and then assign each node a score based on the sum of the shortest path. Yeah. So then why do you do that is because sometimes you want to find an individual within a network. Then if you know that individual, you will know how to influence the entire network in the fastest way by just approaching that individual. Yeah. So just take a look at this illustration. It shows you how they identify the most central person based on closeness. Yeah. So yeah, next.
So now I'll be talking about link prediction algorithms. So basically, after looking at all those networks that we have, are we able to predict the most likely number of links that can happen in the future? So we can approach this using similarity metrics, and there are two types of metrics. The first is common neighbors. Basically, it's the idea that if you and another person share the most number of neighbors, there's a higher chance of you creating a link between you two in the future. So for example, between node A and D, they both share two neighbors, whereas between A and E, they only share one neighbor, which is B. So in this case, A and D have a higher chance of creating a link in the future. The second matrix is the preferential attachment. Basically, it's the idea that if you and another person have a lot of neighbors around you, you will have the higher chance of creating a link. So in this case, A and C have the most number of neighbors around them, whereas people like B and D do not have that many neighbors around them. So in the future, there's a higher chance of A and C actually creating a link between them. So now that we've talked about a link analysis, we're going to go into use all the information and go into looking at how link analysis can help investigations in investigating criminal networks. So link analysis can be a very good tool for investigators to help them visualize complex links between different entities in an investigation, and that may be difficult to communicate or conceptualize just by looking at cases individually. So entities can be people, places, and evidences about the case, and these entities can have their own characteristics that help create links, and these links can be one-sided or reciprocal. So link analysis is a great tool to help them visualize outliers and predict certain patterns in target-centric investigations. So now we'll be doing a demonstration of how this can actually be used. Okay, so this is the software. This is a software developed by Tom Sawyer's criminal network. Yeah, so this is software developed by this company to help investigators get a better idea of how all these criminal networks work. So this is dummy data set, but basically this is the data of crimes that have happened in America from 2018 to 2010. So for example, as an investigator, I want to look at the number of burglaries that have happened in the recent, maybe in late 2008. Yeah, maybe 2010. So I just changed the slider here to focus on a certain period of time. Right. See, and immediately you can see that now they have different little subsets that we can actually look into. So let me see. But this is quite complex, so let me just narrow it down a little bit more. Okay, so basically what this is doing now is that it's helping us to focus down onto very specific cases. And for example, let's say I said burglary just now, right? So if I change the filters to match that, we can now see that we're looking at very specific clusters of crimes that are happening. So let's say I want to focus on this subset of people in this network. Like from this point of view, I can't really tell what the pattern is, so I can try to put it onto, look at it from a different perspective. So let me see if we can see a pattern if we can look at it from a geographical point of view. Okay, so from here you can see that there might actually be a pattern here. There are these three crimes happen to be happening along this street. So this is something that maybe might have not been possible without the tool, this visualization of the pattern, and it could be useful to the police in investigations. Okay, so now maybe as an investigator, I want to see if there are key people in this criminal network that we want to investigate. So looking again at the same subset that we had before, I want to see if there are specific clusters of crimes that happen around certain people. So what this will do now is that will show us different circles of crimes around different people and see just how many crimes are related to the same people. Okay, now it's working. Okay, yeah, so now you can see that there are different clusters. So like let's say we can zoom in on specific clusters of people. That's like, for example, this cluster, because it looks very populated. So we can see that relating to these few people, there seems to be a lot of focus on, for example, vehicle-related crimes. So if I put this on an incident map, for example, you can see that there are a lot of incidents going on. You can't actually identify a certain pattern. So now if we look at their network, for example, for like who they are communicating with and all that, then maybe we can see a pattern. So sorry, the software is a little bit laggy, but okay, sorry, there it is. Yes, now they have identified for us key people in the networks that have the most relationships with different gangs and different incidences. You can see how this is link analysis can be a great tool for investigators to really get a bigger picture of what's going on. Yeah, so that's our presentation. Thank you.
Questions for Kaelyn and Kyna? So that's to analyze crime that has happened, right?
Yes.
Can you predict when crime is going to happen?
And then for now, this is mainly just a tool for them to solve the crimes that are already happening. But I guess using the idea of link prediction, yes, it could be a possibility. Yeah.
Just that we didn't find it.
And there's no software for us to play with. So.
All right, thank you.